Okay. Hello. Good morning, everyone. Welcome to Code and Roy. I'm Dinesh Monti, your helper for this question, and I hope this time it records. The past time I tried recording, it just didn't go that well. It did not record, so I have to go all the way again. So let me explain it to you once again. So the question is given an array of integers. Every element appears twice except for one. So one element is there which appears once, all the other elements in the array appear twice, right? So we have to find that single non-repeating element. So that is our question. Let's see the example. So let's say we have uh, 1 2 2 3 1. So here we can see just clearly that 1 is repeating, 2 is also repeating. There's just a single element which is non-repeating. That has to be our solution. Um, there are many brute force ways of doing the question, right? One way could be to use loops and store the values in an map. You know, you could use a map to store which element is there and what. And again, if it is repeating, we'll just remove that element from our map, or we can use a set if we have something stored in our set. If that is found, if that is found again in the array, we remove this element from the set, and the one which is left behind is the solution, right? So all this will take some order of constant time, or the order of constant space. They can take up to order of n space, right? um, what could we do to optimize that? you know uh, uh, so we can use a very simple concept of bit manipulation over here. So the concept is that of XOR, right? So just a brief recapitulation. XOR of numbers. So if uh, just a second, yeah. So I guess all of you remember this. If both the sides are different, only then the XOR will returns 1. Otherwise, it will return 0 if both of them are same. So that's the table of XOR. So given any two numbers, if you want to get the XOR of those two numbers, we put this element, right? A XOR, this bitwise XOR operator, right? So it does the bitwise XOR operation of both these numbers and gives us the result. So we saw that if both the elements are same, the XOR will return 0. So my first question to you is, what shall A XOR A return? Obviously, it should return 0 because all the elements of A in a given position are same as that of this A at the given position, because it's the same number. So it will have the same bits at the same location, right? So all those bits, when XORed with the same bit, will return 0, and we don't have to worry, the answer will be 0. My second question to you is, um, what shall A XOR 0 look like? What should it look like? For that, I'll give you a hint. If you are so it's a simple answer, but still I would like to give hints for someone. So 0 XOR 1 and 0 XOR 0. So this will give me 0 and this will give me 1, right? So if the number which is XORed with 0 is 1, we get that same number, right? If it is 1, we get 1. If it is 0, we get 0. So finally, A XOR 0. Yeah, you guessed it right. It should be A, right? So A XOR 0 is A, and A XOR A is 0. So these are the basic things. Only these two things will give you the result for this question. So A XOR A is A XOR 0 is 0. How do you approach the question? And one more thing, A XOR B XOR C. Now this is associative, so you could do first A XOR B XOR C, and then you finally could XOR with A. If that would be similar to this one, right? If you first do A XOR B and then with C, so XOR is associative. So yeah, these three things is the maximum thing required to solve this question. Okay, I hope now you can go and solve the question for yourself, right? So this is what you need. Let me erase that. So finally, let me discuss the solution with you quickly. It shouldn't take much more than a minute. So finally, what we have to do is that we have to find XOR of all the elements. Let's assume there are 4 elements, and D is the one which is non-repeating. For generality, let us put D here and then C outside, so it will become better. So what we'll do is that we'll first do XOR. We find XOR of all the elements, right? That is C XOR A XOR B XOR A XOR D XOR C, right? What should be the answer? Because of associativity, we could XOR any 2 elements and their output could be XORed with the final set, right? So C XOR C could be done. Now that will give us 0. Similarly, B XOR B could be done. Where's the B? Okay, I have missed a B, so there should be a B. Okay, as per the question, only one element should be non-repeating, all the other elements should be repeating, right? So the B XOR B will give us 0, A XOR A gives us 0, and finally the D remains. So 0 XOR D will give us 0, 0 XOR 0 0, 0 XOR 0 0, we get 0 XOR D, and that gives us D as the output. So if we do XOR of all the elements, the element which will remain at the end is the element that we wanted as our output, right? Because of the fact that any element XOR with itself gives us 0, and 0 XOR any element is that element, right? So this is the concept that we need to use in this question. So let's see the simple one-liner solution to this. So this is the function that we had to uh, fill up. This was the argument given, constant vector uh, named A. So if we initialize answer equal to 0, it's better if we initialize it to 0, and then we pass a for loop, and then what we do is that we XOR answer with each and every element of the array of the vector. Okay, and then we return the answer. So what we do here is that if we have A, B, so let's go back to the same example that we had discussed a little bit earlier. Just a second. I think I'm getting too much back, so it's better to just get, let's say, A, there was B, there was C, there was B, there was D, there was C, and there was an A finally. So what we do is that we get an answer which is 0, right? 0 XOR B, then 0 XOR B XOR A, then 0 XOR B XOR C. Finally what we get is the solution is the XOR of all elements that we had C, B XOR A XOR C XOR B, dot 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 dot, finally XOR 0. So that gives us the only element which is non-repeating, right? That is stored in our answer, and that is returned. There could be a better variation of this question. Now there could be many variations. We'll be discussing one such variation in this channel, Codin Roy, um, and it will be discussed by me further. But just a simpler advanced version of this is if other elements are even, all elements are even except one, are repeating even number of times, right? Repeating even number of times. There's just one element odd repeated. I know the English is wrong, but for your understanding, I'm giving it in a simpler way. And so what is that oddly repeating element, right? So your answer should be XOR of all the values. If you guessed it right, give yourself a pat on the back, because all the even number of elements A XOR A will give us 0, XOR A XOR A, this will again give us 0, and 0 XOR 0 will give us 0. But when it's odd, like there are 3 A's, what will happen? This will give us 0, but this will give us 0, but this A will not, A will remain, and A XOR 0 will give us A. So just a single A will remain instead of giving us 0. So if we do XOR of all the elements, all the other elements which are repeating even number of times, 2 times, 4 times, 6 times, 8 times, they will give us 0, whereas the one which is repeating oddly, the odd number of times, that will give us non-zero, right? So that should be our solution. Thank you for listening to me with so much patience. I hope you have a beautiful learning journey ahead. Thank you.